Hey guys, I wanted to talk to you about a new formula. The equation for acceleration, final speed minus initial speed divided by time. Let me show you an example. Here's a simple track setup. You can see it starts at point A at the top of a hill over by the turtle tank. The car goes down the hill, up a hill that's not nearly as tall, and then the remainder of the track is quite a bit longer and it ends at point C, a cup. Let's watch a Hot Wheels car in action. From the top of the hill to the top of this smaller hill is a distance of 3 meters. And you remember distance divided by time equals speed. So that's what we're seeing here. Segment AB, you have its distance, 3 meters. The time it took the car to travel that distance, 1.33 seconds. That gave us a speed of 2.26 meters per second. Whereas segment BC was from the top of this hill all the way down to the cup at letter C, which is quite a bit greater distance, 4.8 meters, so it took a longer time, 3.78 seconds, giving us a speed of 1.27 meters per second. Now, the new formula for acceleration, final speed minus initial speed divided by time, is up here for you. You can see that the same speed calculations that I showed you are at the top. So just like before, we still have our speeds of 2.26 meters per second and 1.27 meters per second. Now, to use acceleration is equal to final speed minus initial speed divided by time, we have to take the speed of AB, that's our final speed, minus 0, because I was just holding the car, so it wasn't going anywhere at first, divided by the time that it took the car to travel that distance, A to B, just like we had up here in our speed calculation. So if we take our final speed minus our initial speed that it started at, divided by the time it took to travel, that gives us an acceleration of 1.7 meters per second squared, because it's not just speed anymore, it's speed in a particular direction. This is velocity. So acceleration tells us the velocity of the green Hot Wheels car is 1.7 meters per second. That gives us the speed and the direction. Now, it gets a little more complicated for BC, because at letter B, it was already traveling 2.26 meters per second. And so its final speed by the time it got to C was 1.27 meters per second, minus the initial speed, because it was already traveling at 2.26 meters per second, like we said up here when we were talking about the speed. So final speed minus initial speed, divided by the time it took to travel from B to C, which was 3.78 seconds. Now notice, because we're taking a slower speed minus a faster speed, we're getting a negative acceleration, because it wasn't speeding up anymore, it was slowing down. So that's why acceleration can be speeding up or slowing down or changing direction, because often you speed up or slow down when you change direction. So that was a crash course in acceleration. It shows the velocity of an object, its speed in a particular direction, and you can calculate the acceleration by taking the final speed of the object minus its initial speed that it started at, divided by the time it took to travel that distance.